Hi, everybody. Welcome. Our next speaker, Mario Corchero, will be talking to us about exceptional exceptions, how to properly raise, handle, and create them. Let's welcome him.
Welcome everyone. My name is Mario Corchero. I work at Bloomberg. Well, if you're Spanish, I'm Mario Corchero, but it's impossible for anyone that doesn't have like they are, so don't worry about that. You'll see, I usually do presentations where I like that people enjoy the presentation. They don't see just code and code and code. This is not one of those. There is also, after the talk, I love meeting new people, so please, if you want to grab a coffee or whatever, and we can have a chat, I love that. And don't worry, there won't be any promotion in this talk. There's a lot of Bloomberg there. I work for Bloomberg, but I'm not going to try to hire you. No, I'm going to try to sell you a product, nor sell you a holiday package or anything like that. And don't worry. And in this talk, ideally, if you're a beginner to Python, you'll kind of understand how can you work with exceptions. If you are intermediate, you will see like some catch-ups and like some usual mistakes that you should try to avoid, and maybe you learn some new syntax. If you're an advanced user of Python, you will ideally have some fun because there are some parts of Python that are like, wow, like how does this work? And if you are a C Python core developer, as I see someone here, please keep your questions for yourself. So first of all, and this is why I started this presentation, is you start to speak about exceptions. Like it's so easy, right? Like you just want to raise an exception, easy peasy. You say raise exception, you pass the message there, but then you're like, okay, maybe I'm raising the exception within when I'm handling an exception, right? And in this situation, it's like things start to get trickier because actually maybe if I'm doing that, it's because I'm within a library and I want to hide the exception that I was capturing first. But if I'm within a library, probably I want to have my own exception hierarchy, right? And then it's like, yeah, but there's also like, hey, the key error probably should include some information, so the exception have multiple arguments. And there's also this else and finally and blah 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 blah. So let's go a little bit over it step by step. So first of all, how do we capture exceptions? Really easy. Try catch. Well, sorry, try except. Yes, I was a C++ developer. So try except. Don't hate me for that. Try except, and then you can just put the exception class that you want to match there. And there are different ways to do it, right? You can just put a class, you can just put a tuple of them, or you can just put nothing. You shouldn't do it. But what's going to happen here is basically whenever an exception is raised, it will go one by one on each of those steps and try to match it. So that means that an exception raises, it goes to the runtime error, it tries to match it, go to the next one, go to each of them, and then it will fall into an except. If there is no one that matches, it will just raise it up. Easy, right? Did you know that you can put absolutely anything there? And what I mean with that is that you can have an exception in a variable, you can have a function that gives you an exception, or you can have a typo and have a variable that doesn't exist. And this is not a syntax error. Like your code will happily be compiled into Python, it will be run, and things won't break until you go to this line. That means that if you accept in any of those, that won't be code. So this is why test coverage is important. Make sure that you don't fall into one of those, because if you have a typo, you might have an error in your program and you never visit it until you have an error, when things go really south. So more things about the try except. You will also have the finally, where you can do some kind of cleanup. Basically, whether try raises an exception or not, whatever you have in the finally is going to be executed. Easy peasy. There's also else. This is surprising for people coming from other languages. What all that else does is if there is no exception being matched, if there is no exception that was triggered when you did the try on the code in the try, it will execute the code in the else. It conveys some meaning in the sense of it's effectively what happens if there are no exceptions. In case you wonder what's the difference between else and just put it into a try. So there's a different meaning to it. And additionally, whatever code that you have here, if it erases, it won't be catched by this. So let's start with the fun part. What if we put all of them together? So just look at this, just think on your head, don't worry, we don't do exercise in this talk, no need to raise hands. Just try to think if you know what will happen, like what would be the output of this. If you know some Python and you have worked with this, you would know that it would be 1, 3, 4. And this is easy, right? Everyone is like, exceptions are easy, Mario. Why do you come to speak about this? What about this? What does this function return, right? Will it return 1 because it's the code that you're executing? Will it go through the else? Or will it go through the finally? Right? This is good homework if you want to, to look into this. So what's actually going to happen is that it's the one in the final that's going to be returned. So the output of this would be 4. If you want to understand why that happens, I would recommend that in the latest version of Python, like the one in master, you use this.this to disassemble the code, and you can see what's actually happening. And the key is like the return is not a bytecode as many others, and it will be only the last one that's being returned. It's really cool, really, really cool. Okay, so this is something that goes to my heart. I don't know if you saw past year, there was a gentleman that did that presentation about logging. It was amazing. You have to see it in YouTube, okay? So I'm going to fall into logging based on what he spoke. So whenever you are handling an exception and you want to log about it, all the logging methods that are in the logging library, whether you have a logger or not, a logger or you want to use the global login, all the methods have this argument called xinfo that will log the exception with the traceback. This is really handy. Don't try to do it yourself. I know many people try to print the traceback and the error message. Don't try to do it yourself. You have this beautiful argument. When I discovered it, I was like, wow, I had this thing being my whole life. And it will just print the whole traceback with all the information that you need. If you're doing this, write a better error message than the one I did there. Usually, whenever you're logging on an exception, don't just say that an error happened. Explain where did it happen and maybe what's going to be done with it. But what's interesting is like when we are in this situation, there are usually 2 kind of ways that you might want to log about exceptions. There is in all the loggers and everything, there is a shortcut called exception, which basically logs on error level with this xinfo argument already set to true. So when you are handling an exception and you want to log, there are usually 2 ways. You might want to, it might be an unrecoverable error, and in that situation, you probably want to log an error, and that's it. Or you might want to log something in info to help you debug, and then rewrite the exception. Why do I put time on this? Because in the sense of Python, it says errors should never pass silently unless it's explicitly silenced. That doesn't mean that you should transform 1 error into 2 errors. Because if you're doing something like this, which is basically you capture an exception, log an error, and then rewrite, now you have 2 errors. And what's worse than 1 error? You guessed it, 2 errors. So if as a user now I have to deal with code like this, the problem is, let's say, and this happened, a DBA2 adapter of a database might, for example, raise an exception and log an error because I'm trying to insert a record and it's violating a primary key, right? So the person that designed the library thought like, hey, it's a really good idea that not only I'm raising an exception, like a primary key violation error, but I'm also going to log a warning. That's painful. And that's painful because when I'm writing code as a user of the library, I might rely on that as a feature, and that might not be an error for me, right? I might be able to handle that exception cleanly and just say like, yeah, I was trying to insert something, I know it's there, okay, so I will update instead, for example, if I want to implement absurd on top of it. But if you're logging an error, you're giving me 2 errors. You're giving me the exception, and you're giving me the error. So then I have to choose, what do I do when I get the exception? Like, if, for example, I wanted to suppress it. And quite often what I do is I'm going to shut the logger of that library. Okay, so something else, and you see this a lot, if you don't want to log the traceback and everything, but you want to log the exception, like the content of the exception, always, always, always please use the wrapper of the exception. If you, like, yes, when you log, you know this %s that appears everywhere, so the s can be changed for everything. That's a string interpolation syntax. And one of them is R, and if you use R, it's going to use the wrapper of the exception rather than the string. Why does it matter? Well, because let's say that you create an exception with the text it broke. If you try to print the string of it, it will just tell you it broke. If you print the wrapper of it, it will be the exception with the text. This is important because if I create an exception without argument, you're going to get an empty message. How useful is that, right? Also, if you, for example, have like a really broad exception catch, like you just say except, and then you log the exception, you will have no way to differentiate between a value error and a key error. I'm sure all of you have seen this beautiful log in the middle of the night where it just says, error happen, data. That's usually because it's a key error that just had data in it, and you have no clue of what happened. So if you use the wrapper instead of string, you will be able to get some more information. And I need some water. Okay. So I don't know if you went to the garbage collector talk, but basically that's Pablo Galindo talk. I don't know if it's here. He was doing this talk. We worked together. And he was doing this talk about the garbage collector, and I just saw that he stole this slide from me. So same of you wherever you are, because now I cannot say. But basically, something really interesting about when we are capturing an exception and this exception clause is that if you have a with statement and you do with blah 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 as blah blah blah, this object will outlive after this context. For exception, that's not happening. If you wonder why, like this is gonna fail. If you do this, like E is not defined here. And this is going to fail if you can get more information in this pip. The issue basically is that like the exception object has a traceback, the traceback has a string frame, and it will link back to the exception, generating a cycle. Like I was speaking yesterday with a core developer called Victor. They was like, yeah, I hate this thing. Like CPython is actually full of like small hacks to get around this and not generate cycles. Okay. So now let's get into raising exceptions. And whenever we are going to raise an exception, oh, that's my region. I don't know what's doing in this slide. It's Extremadura. I'm from there. If you want to visit it, I can make a whole package. You have castles, like Roman temples, these really beautiful cities. That's Cáceres is like UNESCO World Heritage. That Americans love castles. So you can stay in my city. You can stay in a castle and sleep there. Okay. And yeah, this is, I know I'm in the US, so Spain is there in Europe, okay? Okay. So let's see how can we raise exceptions. No more spam, don't worry. Let's see how can we raise exceptions. You can, whenever you raise an exception, you can just create an instance of an exception. You can pass all the arguments here, or you can just pass the class and it will create the exception without any arguments. But that's the fun part, whenever you want to raise an exception, when you are capturing an exception, right? You will see a lot of code like this. And the problem is, whenever you do this, what's happening, what you're saying here is that when you are handling the exception, something failed. It's not, many people do this trying to kind of like convert an exception, but what you're doing here is that you're basically failing to handle the exception. And you can see here that if you just run this and see the traceback, you're going to see that it effectively says, during the handling of the above exception, another exception occurred. This basically means I was trying to handle an exception, and I failed to handle the exception. If what you actually want to do is, for example, have an exception, do some logic, and then let the exception raise, what you can do is you can just capture the exception, do whatever you want, okay? And then you can just re-raise. You can see here in the output that effectively, it's like this code never happened. This is like the ARIA stack of the exception handling. Sorry, I was touched with the last chapter of Game of Thrones, so I had to do that. So yeah, you just raise, and this is just going to re-raise the exception. If you want to re-raise an exception that you have in a variable or something like that, you can just do it. You can just do it by saving the exception, because remember, the exception don't leak the scope. And then you can just re-raise it. If you do this, you will see that on the traceback that you get both lines where you re-raise it and where it was originally generated. Okay, so more interesting, especially when you are designing a library and you want to some kind of like translate exception. You can, if you are one of those blamer people, you can just create an exception and say like, hey, this is the exception that I'm raising, but the original fault was from this other one. So this is just a way to, if you want to like handle exception and translate it into, for example, your own hierarchy, but you still want to expose the original exception that happened. So you can see here that like Python will tell you, yeah, the above exception was the direct cause of the following exception. So here you have your exception, and here you have the original exception. Also, in this object, in the new object that you are capturing, you have an attribute called dunder cause, where you can access the original exception. But many times you don't want to expose your internals, right? Like, for example, let's say you are writing some code and you are using your lib, but then you might move to request or something like that in the future, and therefore you just want to hide everything that's related to the implementation. You can do that by just doing raise from none, and that basically allows you to hide everything that happened. So nothing to see here. It's a whole new exception. And this is a really good way to kind of like design your own exception in a library without exposing the ones of your implementation. Yes, so that's how it look. You have no trace of the older exception. It's totally hidden. Now, something that you see a lot, and I mean a lot, not is worrying, but I'm sure that if you look in your source code, you would find some of those. Not implemented is not an exception. Okay, not implemented is something that you use when you're when you're implementing operators for your classes. What people usually want to raise is not implemented error, but there's 37,000 hits raising not implemented in GitHub. And the problem with this is that you see many people actually test this code, and they might do, like, for example, they do assert that this raises exception. And guess what? This is actually going to raise an exception, because whenever you try to raise not implemented, because whenever you try to raise an exception, it has to be a base class of exception, it's going to raise an exception, but it's wrong. But what's even worse is if you try to accept on it, because if you do something like that, where you accept on not implemented, this code will work, and even if you have accepts afterwards, at the moment that you try, an exception comes past this first one and then goes to the second one, it's going to fail here. So this is a bomb trap. And my guess is that people use raise not implemented because when you are in an IDE or something, you just press tab and not implemented probably appears before the not implemented error. I don't know. It's the only explanation I can see. I can see that the names are confusing, right? But that would be, if I'm using an IDE, I guess that can happen. Something else is whenever you raise in a thread, it can happen that, well, if your exception is not caught, it will print you a beautiful stack that's not really useful many times. So if instead of that you want that whenever you call to a thread to like some kind of like offload the job or something like that, you want to get an exception in your main program, you can do it with, for example, by using futures. If you do that, you can just even if it doesn't return anything, you can just call future of the result, and that's gonna move the exception from that child thread into your main one, which is quite handy because many times you have this program that has a thread that runs something, and you assume that it has worked, right? Because there is no error when you launch it, but it might fail with an exception and you didn't notice it. So by just using futures, you can save from that. And let's now start to speak about creating exceptions. And oh yeah, we have Camon in my region. You know what's that? That's like this the best meat you've ever tried. And like Tereth and Floor, that's really good. Like you have to come to speak with me after for the trouble. So this is the exception hierarchy in Python. Okay, you will see that I've shortened it a little bit, but there are a lot of exceptions that are suitable in many different situations. And the main two ones that you probably want to know about is base exception and exception. And base exception is not the one that you should capture. Okay, you always want to capture whenever you're capturing. Whenever you say I want to capture all the exception, you want to capture exception, and that is because base exception has some exceptions like system exit or keyboard interrupt. So that means that if you are capturing base exception and you press Control-C, it's just going to go into that code handling, and you probably don't want that. So okay, let's start to create. Let's start to see how exceptions are, and then we can create some more exceptions. So first of all, what attributes do we have whenever we create an exception? If you have been in Python for some long, you know that exception has a message, right? You have this exception.message, but no, you don't have it. That's only in Python 2. Okay, in Python 3, we have that has been removed. It was deprecated already in Python 2.7, which is something that surprised a lot of people. Exceptions don't have message anymore. They now have, args. So whenever you create an exception, it's going to have a list of args. It can be from 0 to whatever. The thing is like the thing that might give you the hint that might give you the feeling that it has exceptions is that when you print them, if the args is only one element, it will just treat it as kind of like the message. But there is no message anymore. Okay. Whenever you want to see what was an exception created with and what are the arguments, you just have to go to eargs. There are some exceptions, though, that in the in the constructor give some specific meaning to the arguments based in the position, like for example OSR, I believe. But all exceptions will have this attribute called e.args. You also have a traceback, so that's kind of the traceback of when the exception was created. As we said, this is really painful, and some core developers even complain about it because it can really easily generate cycles. The other day we actually hit a cycle in the socket module. I was debugging a different thing, and I was like, wow, like why is this thing being kept alive? And there was actually a cycle in the socket module due to the exception. Due to the exception traceback. Okay, yeah, so whenever you are creating an exception, please always inherit from exception, never from brain exception, never from base exception. It feels like, you know, it's calling you when you see base exception, right? It's like you want to inherit from that. It's a trap, okay? And that's important because if you inherit from base exception and then you raise that, as a user, if I as a user want to capture all exception, I cannot do except exception anymore. I will have to do base exception, and that's gonna also capture exception that people usually don't want to capture, as we saw before. Also, we said that all exceptions have args. So even if you don't call super here, args are gonna appear, so that's guaranteed for you. This is because actually args has no setting in the init. You can see more about that if you see the implementation of the base exception class. Oh, you should always inherit from exception because you cannot raise anything in Python that does not inherit from. That's not a subclass of exception. Okay, so you start to create exception and you go crazy, like it's so fun, so only 2 lines of code, and then you realize that you probably want to have your own hierarchy. If you have a big library, that's usually a good idea. You can see, for example, worksug, or however you know to pronounce it, requests or SQL Alchemy have really nice, well-designed exception hierarchies. And this is, for example, the one from, I think it's worksug. And basically, you can also, if you want, you can do multiple inheritance with the exception. So if you want, for example, the exception to be captured in 2 different bases, you can do that. You can see that in the decimal module in the standard library. The division by 0 exception inherits from both decimal exception and 0 division error. This is handy because whenever you are capturing an exception, you can be capturing any of those, and if you raise one of those, it will fall into that code path. Also, if your library started by raising value errors, but then in the future you want to change to your own exception hierarchy, no worry, we have you covered. All you have to do is you can inherit from your the base exception of your exception hierarchy, and you just inherit from the previous exception that you want now to change. And this way you won't break users, because if you were to change the type of exception that you raise, that will be effectively a backward compatible change. What else? Oh yes, so if you are coming from C++, well, from C, you might be tempted into forcing users into what's called the Pokemon catch, which is like you catch them all and then you differentiate in error codes, right? So if you want to use error codes, there are some situations where it might be fair. Like for example, here, it's basically forwarding HTTP error codes into like this code attribute. But even if you do that many times, it's good to have each of the error codes as a custom exception, because whenever I'm a user of your library and I'm consuming it and I'm calling your code and I'm going to capture it, it's much easier for me to have like different parts of the code based on the exception that I'm capturing, rather than having to do ifs on the code. Okay, so wow, I went really quick. So basically, racing with whenever you're racing with an except, be mindful of how are you doing it, whether you want to hide the exception or you want to re-raise an exception, or you want to like do a raise from whatever. Whenever you're logging an exception, please don't produce two errors out of 1. So either log as an info and re-raise, or just log an error if it's something you're going to recover from. And whenever you're creating exceptions for your libraries, think if you want your whole exception hierarchy or not. And I think we have time to go through some bonus. Wait. So I'm sure all of you know that this is bad, right? And this is bad because we saw that this is going to capture everything, including, for example, like a keyboard interrupt. But this is as bad as that. So if you try to do something and you have a return indefinitely, this is effectively going to like hide all the exceptions that you have in your code. If you have a function that is actually doing this, yeah, like nothing can stop it. Like if we write this code, for example, it's just import times, sleep for 5 seconds, and in the final you do a print and a return, and then while true, you do it. You call that function. Let's see if I can show you. So you can see that code around this, and there will be no way to stop this. Actually, if you try to do keyboard interrupt, you're just feeding him. Like you see, he likes it. There's no way to stop this program. So be really mindful whenever you are returning in a finally. And with that, I think we have some time for questions.
All right. If you have a question, please just use one of the microphones to ask.
Cool. No questions. You can ask me about Extremadura, the next
I actually
trip.
have one. Hi there.